let's see. All right, now it is recording for real. I'll try not to hit that button again so I don't turn it off. All right, so let's do this. Let's see. Shift Control P, make sure I do the right one. We didn't do rectangular pyramid yet, did we? Was that the next one? Okay. So let's do that one. We did this one? Oh, that's right. We talked. I remember doing this now. We talked about the sides. Well, let's just review it since I got it up here. You guys told me the last thing we did was the cylinder. You didn't say we did this.
Yeah, we did.
We did this before the cylinder?
Yeah.
Oh, did we? Okay. That's my bad. In the book, it's the other way around, so I must have mixed it up. What do you call, like this triangle right here and this triangle right here? There's 4 of them. What do we call those? Call them the sides, right? And what about the bottom? It looks like a rectangle. That would be the base, okay? So, okay, I'm teaching, okay? You can just walk in. Thank you. So look at the base. It's a rectangle. It could be a square as well. I think we mentioned that, didn't we? That a square is a rectangle. So you could call it, but we call this a rectangular pyramid. Remember what all the sides do? They don't just go straight up. They go up to what? 1 point, and we call that the vertex of it, okay? If it's a right, did you write that down? A right rectangular pyramid. If it's a right rectangular pyramid, let's talk about that since we didn't. We did it. Yeah, but we didn't do it with a pyramid, did we? But so it's basically the same thing as the right circular cylinder, okay? Remember we took it from the vertex, and then we took a line that was what?
Right to the base.
Yeah, right to the base, and it's going to hit right, I guess you could say the middle of the base. And yeah, there we go. That looks pretty decent right there. Okay, and if this is a right angle, we would call this a right rectangular pyramid. You follow me? You could have one that's not a right rectangular pyramid and it's oblique. What would that do? That means this wouldn't be just straight up and down. From the vertex to the base would not be perpendicular, but it could be kind of slanted. You see that? So if that, I can't draw that, and I don't think I found a picture online with an oblique, but you could have this kind of like pointed to the sides, so all the corners of the rectangle kind of go up like this at an angle. Everybody see that? Okay, so it's not straight up and down. This vertex wouldn't be straight up and down. That would be called an oblique. We probably won't deal with that too much. I wouldn't worry too much about that. All right, let's see what else we have. Okay. Well, we talked about a pyramid. This is a rectangular pyramid. You could have other kind of pyramids. It doesn't always have to be rectangular. You could have something that looks like this. Let me move this up a little bit. And let me go back to this. Okay. Now, this would be kind of hard to draw, but you could kind of try it. Look at the base of this thing. It's not a rectangle this time, is it? How many sides? 1, 2, 3, 4, 5, 6. Very good, okay? There's 6 sides to this thing. We talked about this in 1-6 when we did 2-dimensional figures. What did we call a 6-sided figure? Do you remember? It's probably in your notes. All you got to do is maybe flip back a page. It's a hexagon, okay? So this is not a rectangular prism. This would be called a what? No. It wouldn't be. We just, right, hexagonal is how we would say it. But you're right. How'd you say it? Hexagonal? Yeah, I think we would say hexagonal, but it's the same thing. I would know exactly what you're talking about, okay? You would spell it the same way. All right, so this is a hexagonal pyramid. Why is it hexagonal? Because there's 6 sides to the base, okay? I could have a triangular prism. What would that mean, a triangular prism? It means your base would be a triangle, exactly. Or it could have an octagonal, right, pyramid. What would that mean? The base is a octagon, all right, 8 sides, right? And I could just keep on going forever, couldn't I? It's a pyramid, right? It's named upon its base, right? But it's a pyramid because at each of these corners of the base of it, right, what does it do? They all come and they meet at one vertex, at one point. Do you see the difference between the cylinder and a cylinder just goes straight up, okay? All the sides just go straight up, okay? But on this one, they all go to a point, and that would be a pyramid. So that's what a pyramid looks like. And we name a pyramid exactly, like somebody said, by the base of it. Whatever shape the base is, okay? Now, it doesn't have to be all the sides equal and all the angles equal. It doesn't necessarily have to have that happen. But a lot of times you see it does. So what if I did this? What if I drew a line straight from the top, perpendicular, and it hit right in the middle? What would that be? This would be a right hexagonal pyramid. Very good. Everybody got that? Okay. If it's slanted, right? If all the sides like slanted to a point like way out here and it wasn't right in the middle of this hexagon, what would I call that thing? Not acute, oblique. Right, we would call it oblique. No, not necessarily, because if this slants out this way, right here would make an obtuse angle down here. So you would have acute and obtuse angles that it would make to come up here. We just call it oblique, okay? Oblique just means it's slanted, okay? The vertex is not dead center of the base. Everybody with me on that? So if it's not over the dead center of the base, if it's off to a side one way or the other, we call it oblique. If it's dead center, right? So if it's from here straight and it hits the center of this thing, I would just call it a right, whatever shape it is. In this case, a right hexagonal prism. We good with that? Yeah. It's not too hard. Again, all we're doing is identifying these things. That's all we're trying to do today. We're not really doing anything with them. Later on, I really even doubt later on we're going to do anything with like area. We might do area, but I really doubt we'll do volume with this thing. I don't know. I think maybe we will. I can't remember. Again, I haven't taught out of this book, so I'm not really sure what this book does. I'm just going by other books I've taught out of. But today, it's super easy. It's just building a foundation. We're just trying to identify what these things are. That's all we're doing today. All right? Let's do another one. See what else I got. Okay, we talked about this before. Let's just put the picture here. So we're still talking about pyramids. Now this is a little different because it's not sitting really on its base. It is sitting on like this part right here. Do you see that? That looks like rectangular, doesn't it? But are all the sides going up to a point or all the sides going straight up? No. This right here, let's see. Yeah, I probably should have done this first. Oops, sorry. I should have done this before I did pyramid. But pretend this was sitting on this triangle right here, okay? Can you picture that in your head? So you got this thing, you just got tilted up a little bit, right? So it's sitting on this triangle. So it's sitting on a triangle. Do all the sides come up to one point?
No.
What would they do? They just do what? They just go straight up. That's exactly right. They just go straight up. So we don't call that a pyramid because, again, a pyramid does what? Comes all the way to just one point. So it's not a pyramid. We would call this a prism. A prism, all right? So this would be, now the base would be a triangle. Again, I didn't find one that sits on it, okay? What's that? Okay. I didn't find one that actually sits on the base right here. Maybe I didn't look hard enough. Probably wasn't even thinking about it. I just saw this and I just copied it. But what if it's sitting on the triangle and the sides just go straight up? We call this a prism, all right? Now, it's kind of like a cylinder, because what did a cylinder do? It started with a base, right, sitting on the table, right, sitting on the floor, whatever, and then all the sides went just completely straight up. And the base, the bottom of it, was the same as the top, okay? The base, so even though we think of base always being on the bottom, the top is exactly the same thing, so you could consider the base being the top as well. Does that make sense? So if you look at this, if it's sitting on this blue triangle right here, again, we're tilting it up. You got to use your imagination a little bit. If we tilt this up and it's sitting on the triangle, what is the top? The top is exactly the same thing as well, isn't it? Do you see that? So this right here would be the top of it. All right? And this right here would be the bottom of it. You have to use your imagination because it is a three-dimensional object and it's on like a two-dimensional surface. Okay? So you have to look at it and say, okay, I think I know what they're doing with this. It's just a matter of just kind of getting used to it. All right? All right, we okay with this? So that would be called a prism when the sides go straight up. All right? I don't know. Let's just draw one. We could draw a, let's do like a, oops, oh my goodness, what was that? What did I just do right there? I slanted everything. How in the world did I do that? And I hit Control Z and it just went back on this. What did I just click? That was weird. Oh, well. I'm just going to move up. I'm going to zoom in a little bit so it doesn't look slanted. There we go. That's a little bit better. So what if we did this? I'm going to go here. Oh, it's all slanted again. That's the weirdest thing. Well, I'll just make it go in. So my whole desktop thing is all slanted, or at least this background, and it slants everything else. I don't know what I did. That was weird. Just have to deal with it, I guess. All right, so here's actually, let's make this a little bit smaller. And I'll tell you what, let's make this a rectangle instead of a square. If I'd have done the first time, I wouldn't have slanted everything. All right, so watch what we can, oops, sorry. Okay, now I can do this. So what if I did like this? You ever draw a box like this? Okay. Like that. And like this. Gavin? You got a question? What's your question? Oh, put your hand down then. Looks like you have a question. Anyway. And we'll go to here. All right, there you go. Again, it looks like it's sitting on the bottom of it, but you got to pretend that it's sitting on this. This would be, I guess, actually, to tell you the truth, you could think of it as sitting on that big rectangle on the bottom. If you want to put dotted lines in here, I'm terrible at drawing these three-dimensional things, but you could put some dotted lines in here, like to here, to kind of see the back of it, right? You ever see that in books? Sure. So you could look at it a couple ways. You could look at this, the base. So if this right here is the base, then this rectangle up here, right, you can't see the back of it because it's kind of hidden. So from like dotted line here, you could consider that the base. Or whatever it's sitting on, that could be considered the base. So you could call this a rectangular prism, right? The other one, what was the other one? A triangular prism? So this one would be a rectangular prism. Again, what's the difference between a prism and a pyramid? A pyramid all goes up to one point. A prism, all the sides just go straight up, okay? Everybody got that? Just straight up, right? So if you consider like this big rectangle that it's sitting on, the sides just go straight up, straight up, straight up. So the two bases are exactly the same. On a prism, you have one base. You don't have two bases because it all comes to a point. But on a prism, you have two bases. You got on the top and you got on the bottom. I don't know why. Let's see. Does this? Oh, there we go. Now it's slanting. I don't know how to make it at 0. I see those numbers. Anyway, close enough. Whatever. I'll deal with it later. All right. Let's see what else we have. Now we have. Oh, here's a crazy word. Again, there's no way in the world I'm going to ask you to draw these things. These things are too complicated to draw. But again, like I've said like 2 or 3 times today, I could give you a picture, and then you just have to identify it. That's all that is, okay? And these are called polyhedrons. Yeah. All right. And on page 41, I didn't write out a list, but let's just take a look at it. On page 41, you have your books open? On page 41 at the top right, it gives you all kinds of different polyhedrons. I should have like taken a picture of it and stuck it on here, but I didn't. Actually, let's do this. Let's Google it. Maybe there's a list where I can just find it real quick. Oops. So a list of polyhedrons. So there's a few of them. It's not all of them. I think if you're watching on YouTube, you can't see this. I thought for sure they'd have somewhere where they give you just like a list of all the polyhedrons, since that's what I typed in. Let's just go to this. Maybe just on regular Google they'll have it. No, don't want that. Sorry. I should have been. I thought I was prepared for this. Oh, oh, wow. There you go. Oh, my goodness. Now, I don't know. I don't know those. I can't even save most of those things. 162 sides. Wow. That's crazy. All right. So anyway, here's a list. Again, if you're watching on YouTube, you can't see this because of the way I have this recording. But here's a list up to 20. And I think in the book, they go up to 10, then they skip to 12, and then they skip to 20. All right? So let's write those down. All right? So first of all, let's just put a picture on here first just to show you what a polyhedron is. We're not going to deal with this very much at all. Let's just go to this one. All right, why isn't it shift? There we go. Okay. So there you go. So the definition says it's a closed surface made up of polygonal or polygons, all right, or polygonal regions. Each polygon region forming the surface is the face of the polyhedron, all right? So this would be considered a polyhedron. And it's got a base. They all come up to a certain point. They got all these. So all the surfaces are triangles, okay? So it's not like you start with a rectangle, it goes to a point, and then some of the sides are triangles. All the surfaces are triangles. So if I took, how many surfaces are on this? Remember, it's got a back to it as well. Well, you got 1, 2, 3. It looks like there's 5 of them, isn't there? Yeah. Like, you don't see them, but you kind of have to envision there'd be like 2 more sides on the back there where you can't really see. Okay? I'm sorry, there's probably only one other side, right? The back of it. Okay, you're right. You're exactly right. I was not thinking correctly. So you're absolutely right. So on the back of it, there would just be one more side. So let's say it again. How many sides would this be? 4 sides, okay? So we have words for all these, and we start off with 4. Because you can't have one that's 3. So if you have 1, 2, yeah, you're not going to be able to have a closed figure with just 3 surfaces, okay, when they're all the surfaces are exactly the same, right? So all of these surfaces are exactly the same, and you're not going to be able to have one that's got 3. Really, I've done so little anything with polyhedrons in the past. All we're going to do is identify them, and that's it. That's all we're going to have to know about these things, okay? But people like in engineering and architecture and things like that, they deal with this stuff all the time because you've seen probably crazy-looking buildings that have all these different shapes to it and all that. So, yeah, people actually do use this a lot. You've probably been in buildings that are polyhedrons, but I think you ever been to Epcot and that big circle building? I don't even know what they call that, but they call it the golf ball. That possibly is a polyhedron. Okay, I can't guarantee it, but maybe you could look it up sometime. Just Google it and see what it is. See how many surfaces make up that whole thing. All right, that'd be kind of interesting to see. All right, anyway. So there's this 4 sides. So let's do this. Let's put this in a different color. There we go. All right, so what we're going to do, and each of the sides, they actually call a face of the polyhedron. Okay, instead of a side, they call them the face of the polyhedron. And then what we're going to do is we're going to write down the name. Okay, some of these are pretty crazy. So how many faces? This one right here, how many faces does it have? 4. It's got 4. Okay, and we call that a tetrahedron. So it's just these prefixes, really, is what you got to know. And then some people might say hedron. I just kind of say a little quicker, tetrahedron, okay? So that's kind of how I would say it, a tetrahedron. So tetra, okay, would be the prefix for 4. There's other prefixes for 4, but that's the one that we learned right here. Okay, if you have 5, What did we learn about a five-sided figure? It was a pentagon, and that's exactly what they call this, except it's a penta what? Hedron, right. All right, so penta. And then a six-sided, and we learned this, again, right. We call this a hexa, right, because that's the prefix for six. Hexahedron. And I have a couple examples of these. I'm not going to show you examples of every single one of these, but I will show you a few of them, and so you kind of know what they look like. Okay, 7 is exactly what we said when we did a two-dimensional hepta. Okay, heptahedron. So far, so good. Tetra was the only one different, right? Because what did we call it before? We called it quadrilateral, right? So we called it a quad, but they used tetra on this one. 8 is what we think it should be. What should it be? Octa, right? So it's octahedron. Pretty easy. I think they go to 9. Yep. Same thing with 9. We did it again. It's Nana, not Nana, N-A-N-A, who's a senior at our school, but it's N-O-N-A, and then hedron. All right? Pretty easy. So I'm just thinking off the top of my head. I haven't made up the quiz for this yet, but I'm thinking off the top of my head. I could give you a question. What is the name of a 7-faced polyhedron called? And then you would just write what? Heptahedron. Okay? You with me on that? So that should be a pretty easy quiz, shouldn't it? It's got to be pretty close. What's the prefix for 10? What did we use before? We're going to use it again, if I can spell it right. Okay, decahedron. So far, so good. These haven't been really hard. Tetra was the only one that's kind of weird. Now, 12, I think we ded this with 12-sided figure. What did we do with a 12-sided figure? What was our dodecahedron. All right, so these are pretty much what we did before. And now, we didn't put an 11 in here, and they jump all the way to 20, all right? And this is a little different. It's icosa. Okay? I would have never known this until I looked in the book and I saw this word right here. But icosa, what do you think's the end of it? Hedron. Okay? Again, if you go look at this, they've listed a whole bunch of them. There's 11. Hendecahedron, dodeca, 13. I don't even know how to say that. Trisecadecahedron. All right. Look, they got all these numbers. There's your 20 right there. All right. No. I probably wouldn't either, so I wouldn't. I've never even heard of those, okay? I don't think they're all that important. Okay, let me just show you some examples of some more, and then we'll quit, all right? So here's a, did you see what this was called when I brought it up? See how many faces are on this thing. Remember, it's just the ones on the outside, nothing inside. It looks like you got a rectangle inside. We don't count that. Just the faces. It looks like you got a top and a bottom. Yeah, so you got 1, 2, 3, and then back here would be 4. Then it's exactly the same on the bottom, so there's 8. So we call that a what? Octahedron. Okay, and they call this a, now they get a little more specific on this one. They call it a regular octahedron. Why regular? We talked about that earlier. What does it mean by regular? All the sides are what? Equal, okay? The same or equal, and all the angles are equal, okay? All the sides are equal, all the angles are equal. That's why they call it a regular. But I'm not going to worry about, I'm not going to worry about a regular. Just know octahedron. Just know how many sides. Just be able to count up how many sides. Let's do another one. Now you can kind of see it on there already. Did you guys read it when I was pulling that thing up? Nobody? Almost looks like a soccer ball, but it looks like a kind of a clunky soccer ball. Wouldn't be very smooth because it's not circular, but yeah. It is a whole bunch of pentagons, exactly right. Any idea how many sides that thing has?
12.
Yes, there are 12. And what do we call it? 12-sided? Dodecahedron, right. We call this a dodecahedron, All right. I'd probably give you ones that are a little more simple, a little bit easier to count the sides. Okay, but it's just an example, right, of what these things look like. Okay, and it's probably regular dodecahedron, all right, because it looks like all the angles and sides are equal to each other. Okay, all right. I think I got one more of these. Okay, this is pretty looking. They put all kinds of colors on this one. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you probably got the same amount on the other side that we can't see. Right, so how many do you think sides are on this one? Looks like there's 20 on this one, right? So what's that name? Icosa? Yeah, icosahedron. Icosahedron. All right? And again, we're not going to really worry about like how to find the area or the volume or anything like that. We're not going to do any math with this stuff. All we're going to do is identify them. Pretty much, I think that's all we're going to do. Yeah, I think that's pretty much it right there. I don't think I had anything else. Yeah, that was the last one that I had right there. Okay, so let's give a little homework assignment with this. You have your lesson plans in front of you probably, or you got it somewhere around. Do you keep your lesson plans in your notebook? Anybody keep a folder or anything like that? You should keep a folder, okay? So you should always put your lesson plan in your folder so you always have it with you and you know what it is. But here it is. So it's section 1.7. Make sure you write section 1.7 on your homework. And then it's pages 42 and 43. And we're doing 1 to 32. And again, you're really not doing any math with stuff. All you're doing is answering questions that they have about it. And if you know what these shapes are that we talked about the last 2 days, you should be able to answer those questions all. Oh, yes, sir. Yeah, you got 10 minutes, okay? So let's start it now, okay? So you get a good start on it, and then you won't have to do so many tonight. But let's work on it. This is not free time, okay? This is 10 minutes. That's a lot of time, okay? So don't say, Mr. Hammer, we only have 10 minutes. No, you got 10 minutes. That's a lot of time. Actually, we don't. We only have 5 minutes. It's Wednesday. That's still time to get started. Do a couple of them. Look at them, all right? See what you're in for. And there we go.